Scientists spent decades studying this spider, and they still got it wrong. Deep in the tropical forests of Southeast Asia, hidden among towering trees and ancient bark, lives a creature that challenges everything we thought we knew about spiders. It doesn't spin giant webs. It doesn't hide underground. Instead, it climbs. This is the tiger tarantula, one of the largest spiders on Earth. And until recently, scientists didn't even know what it truly was. This is evolution at its most unexpected. I am Williams, and you are watching Insane Evolution. For years, scientists believed this spider belonged to different species, different names, different classifications. But new research revealed something shocking. They were wrong. What scientists thought were multiple spiders were actually one single species. Its real name is Omothymus schioedtei, the Malaysian Tiger Tarantula. This spider can stretch its legs nearly 22 centimeters wide. That's the size of a human hand, spread open. Yet its body remains compact, muscular, and perfectly balanced. Not bulky, not clumsy, built for precision, built for the trees. For millions of years, evolution followed one path. Then suddenly, it didn't. Tarantulas are ancient creatures. Their ancestors walked the earth millions of years before humans ever existed. Historically, this evolution is called evolutionary detour, an evolution that can only work with the genetic and physical baggage inherited from ancestors. It modifies what is already present, step by step, rather than creating an optimal design from scratch. Most tarantulas stayed close to the ground, digging burrows, waiting for prey. But evolution doesn't follow rules. In the dense rainforests of Southeast Asia, some tarantulas took a different path. They climbed. Tree-dwelling life forced change. Longer legs for grip, lighter bodies for balance, faster reactions for survival. And slowly, generation by generation, the tiger tarantula was shaped. Its dark body and golden stripes aren't decoration, they are camouflage, a pattern designed by evolution itself to vanish against bark and shadow. Forget the image of a spider waiting in a web. The tiger tarantula hunts silently. It stalks insects along branches, lunges at lizards, and even captures small frogs. That is why it is called the silent hunter. In the trees, there are no burrows to hide in, no second chances. Speed means survival. Its movements are fast, calculated, almost surgical. One mistake and it becomes prey itself. This spider didn't evolve to be scary. It evolved to be efficient. Being a hunter doesn't mean you're safe. So what hunts the hunter? Despite its size, the tiger tarantula remains in state of vulnerability. In the rainforest, everything is prey to something else. Birds are its greatest threat, especially nocturnal hunters like owls with sharp vision and silent flight. Large reptiles, arboreal snakes, tree-climbing lizards, they don't fear venom. They strike fast. And then there are the most terrifying predators of all. Parasitic wasps hunt tarantulas with surgical precision, stinging them, paralyzing them, and laying eggs inside their bodies. The spider doesn't die immediately. It becomes a living incubator. evolution is cruel. The tiger tarantula is not alone. Across the world, tarantulas have evolved in terrifyingly creative ways. At this point, evolution has gone wild. In South America lives the Goliath bird eater, the heaviest spider on Earth, capable of overpowering birds. In Cuba, a species with long, feather-like legs looks almost unreal, like something from another planet. And in some species, male tarantulas evolved absurdly long reproductive limbs, not for attraction, but to avoid being eaten by females. This is evolution without mercy. Adapt or disappear. Male tiger tarantulas live a short, dangerous life. To reproduce, this spider must risk being eaten alive. When maturity arrives, the male leaves safety behind. He stops hunting, stops hiding, and begins to wander. Driven by instinct, he searches for a female, knowing the journey itself may kill him. When he finds her, the danger multiplies. Female tarantulas are larger, stronger, and sometimes hungry. One wrong vibration, one misstep, and the male becomes food. To survive, evolution armed him with a strategy. He uses long, specialized appendages to keep distance, delivers his genetic package quickly, and retreats immediately. There is no courtship, no second chance, just precision or death. But the mystery doesn't end there. Very little is known about how often the tiger tarantula mates, how many offspring survive, or how long females protect their egg sacs. Much of its reproductive life remains hidden, high in the trees, far from human observation. So why do tarantulas evolve so extremely? Isolated jungles and islands are evolutionary laboratories. Here, species are cut off from the rest of the world. No escape, no backup. Every small advantage matters. A longer leg, a darker stripe, a faster strike. Over thousands of generations, those tiny changes become monsters, giants, legends. The tiger tarantula is not an accident. It is the result of pressure, isolation, and time. Tiger tarantula's evolution remains a mystery. Millions of years should leave answers. This left questions. We know what it is. We don't. Despite its size, this spider remains poorly understood. We don't fully know how it reproduces, how long it lives, or how climate change will affect its future. Deforestation threatens its habitat, silently removing the trees it depends on. Entire evolutionary stories could vanish before we ever understand them. The tiger tarantula is not just a spider. It is proof that evolution never stops experimenting, never stops reshaping life. It reminds us that the most incredible creatures on Earth are not always the loudest or the most famous, but the ones hidden high above us, watching, waiting, forged by millions of years of survival. This is insane evolution.